Hey guys, I just wanted to do the first problem, equilibrium problem with the ice table that we did. I would like to try that again, just so we kind of get familiarized with the plus or minus x in our ice table. So I've set up our ice table for the problem. A researcher fills an evacuated 2-liter flask with 0.200 moles of HI gas and allows the reaction to proceed at 453 degrees Celsius. The reaction is 2HI is in equilibrium with H2 and I2. So the first thing we do for these is, first of all, we set up our ice table, my equation and my initial, my change, and my equilibrium, as well as setting up my equilibrium expression. K is always equal to products over reactants. In this case, my products are H2 and I2. My reactants are HI, and I have squared because my coefficient is 2. So now, it says initially, a researcher fills an evacuated 2-liter flask with 0.200 moles of HI gas and allows the reaction to proceed. The evacuated flask means that all I have in the flask is this HI, and I have nothing else to start with. Now, when I think about the change in a reaction, what I have to remember is that my coefficients play a part in the change that I will see. So my ratio here is a 2 to 1 to 1 ratio, so every time I lose some of this, my ratio is in a 2 to 1 to 1 ratio. So I know that I will be losing some of my reactants because, again, I cannot go in the reverse direction when I have nothing to start with. So I have my minus 2x, I will lose 2x, and I will gain 1x. I will gain 1x again because of my ratio in my balanced chemical equation. So what I figure out is at equilibrium it tells me I have a concentration of HI of 0.078, but I was not given my equilibrium concentrations of hydrogen and iodine gas. Now, the whole question is asking me to solve for my equilibrium constant, my Kc, trying to solve for that, which means I'm going to need my concentration of H2 at equilibrium, my concentration of I2 at equilibrium, and my concentration of HI at equilibrium. At this point, all I have is my concentration of HI, meaning these two x's I have to figure out somehow. Now, the way that I can figure out what that change was here is by looking at my initial concentration of HI, my final concentration of HI, and my change. I know that my final concentration of HI, 0.078 molarity, was equal to my original 0.100 molarity minus the change that I had, minus the 2x. So I'll write this again down here because there is a glare. 0.078 molarity is equal to my 0.100, my initial, minus 2x, which is my change. Now when I solve for x, I find that x is equal to 0.02, 0.011 molarity. That is my change. That is the amount times 2 that I lost for HI. So minus 2 times that 0.011 molarity, that is the amount of moles per liter of hydrogen that I gained, meaning at equilibrium, that's exactly what my concentration of H2 is, 0.011 molarity. Also my concentration of I2, 0.011 molarity. So now I have found my concentrations of everything at equilibrium. I have I2, I have H2, I have HI at equilibrium, and I can solve for Kc. So, just to plug that in, Kc is equal to my concentration of H2 at equilibrium, 0.011, times my concentration of iodine at equilibrium, 0.011, all over my concentration of HI at equilibrium, 0.078 molarity squared, again because my coefficient is 2. I solved for this and I found my Kc. I'll let you guys do the calculator work. Alright, next video is coming soon.